If you have ever followed an aviation mystery, this is the one that refuses to let go. Malaysia Airlines Flight MH370 vanished in the early hours of March 8th, 2014, and more than a decade later, the world still does not have what everyone wants most: the wreckage, the flight recorders, and the definitive chain of events that explains exactly what happened. What we do have is a long, complex history of searches, clues, false leads, scientific breakthroughs, and the slow, painful reality that the ocean can hide almost anything. We also have a new chapter: the most recent search efforts that restarted after years of debate, new analysis, and improved technology. This is the full story from the night MH370 disappeared, through every major search phase, and into the newest search campaigns and what they are trying to do differently. And when we discuss theories, we will call them exactly that: theories, because without the wreckage and the flight recorders, certainty is still out of reach. MH370 took off from Kuala Lumpur just after midnight local time, scheduled to fly to Beijing. On board were 239 people, passengers and crew. The flight was routine at the beginning. Then something happened that turned one of the most tracked commercial flights in the world into a ghost. The last known voice transmission from the cockpit came during a handoff between air traffic control sectors. It sounded normal: no distress, no urgency. Soon after, the aircraft's transponder stopped transmitting, meaning the plane would no longer appear on civilian secondary radar in the way controllers are used to seeing. That alone was alarming, but it was not yet a clear disaster signal. Transponders can fail, systems can be turned off, but then the plane also stopped responding as expected to routine communications. In the first hours, the assumption was that the aircraft had gone down somewhere near its last known location over the South China Sea. Search aircraft and ships began sweeping the waters near where the flight was expected to be. The world watched a familiar pattern unfold: a missing plane, a widening search area, officials issuing cautious statements while hoping for a quick resolution. Then the story took a dramatic turn. Military radar data indicated that the aircraft may have deviated from its planned route, turning back across the Malay Peninsula and heading west. That possibility opened a terrifying new reality. If the aircraft had turned away from its route, the crash could have happened far from the initial search zone, across vast stretches of ocean. A few days later came the data point that ultimately redefined the entire investigation. Investigators confirmed that the aircraft had continued to communicate with a satellite system for hours after it disappeared from civilian radar. These were not phone calls or text messages. They were automated, routine handshakes, brief signals exchanged between the aircraft's satellite communication unit and an Inmarsat satellite. The content of these handshakes did not include the plane's location, but the timing and signal characteristics could be analyzed. Those satellite handshakes created what became known as two broad corridors: a northern corridor stretching across parts of Asia, and a southern corridor reaching deep into the southern Indian Ocean. Over time, the evidence increasingly favored the southern corridor, a conclusion that would shift the search into some of the most remote, stormy waters on Earth. For families, that shift was brutal. The southern Indian Ocean is enormous. The nearest land is far away. The sea state is often harsh. Depths can be several miles. If the aircraft went down there, recovery would be extraordinarily difficult. The initial search was chaotic by necessity. Multiple nations participated. Aircraft scanned huge areas. Ships dragged sensors and listened for underwater locator beacons, the acoustic pings that the flight recorders can emit for a limited time. But those beacons have batteries that last only so long, and in deep, noisy ocean environments, detecting them is not guaranteed even under ideal conditions. As days turned into weeks, the search became more technical and more focused. Experts began to use satellite handshake analysis to define a line called the seventh arc. Think of it as a curved line on the ocean's surface. It represents places where the aircraft could have been when it made its final handshake with the satellite. The aircraft's most likely last position was believed to be somewhere along that arc in the southern Indian Ocean. But the arc is not a pinpoint, it is a line across a massive ocean. From there, the hunt became a deep sea search. Specialized vessels used sonar to map the seafloor and look for wreckage. The Australian Transport Safety Bureau, working with Malaysia and China, led much of this effort. The scale was immense. Over time, the underwater search covered on the order of 120,000 square kilometers of seafloor, an area larger than many countries. This search lasted for years and ended in January 2017 without finding the main wreckage. That moment when the official underwater search was suspended was a second trauma for families, not because hope ended, but because hope became less structured. Without an active search, the mystery felt like it could drift into permanent limbo. But even during those years, the ocean did not stay silent. In July 2015, a major breakthrough happened in the form of debris. A large piece of aircraft part, a flaperon from a Boeing 777 wing, was found washed ashore on Reunion Island in the western Indian Ocean. Investigators confirmed it came from MH370. Later, additional pieces believed to be from the aircraft were found along the coasts of places like Mozambique, Tanzania, South Africa, Madagascar, and nearby regions. Some fragments were officially confirmed, others were deemed highly likely. Each piece strengthened the conclusion that the aircraft ended in the Indian Ocean. But debris also raised new questions. Drift patterns can be modeled, but ocean currents are complex. A part can travel thousands of miles. Debris does not point neatly back to one location. Instead, debris becomes another input into probability. Over time, scientific drift studies refined estimates, suggesting that certain portions of the seventh arc were more likely than others. Oceanographic modeling was used to reconcile where debris was found with where the aircraft might have entered the water. Meanwhile, Malaysia released an official safety investigation report. That report compiled what was known and what remained unknown. It included analysis of communications, radar, maintenance records, and possible scenarios, but it could not identify a definitive cause. The absence of wreckage meant the report could not confirm whether the event was mechanical, accidental, or intentional. This is where theories began to expand. One widely discussed theory is pilot suicide or deliberate action by someone in the cockpit. This theory points to the aircraft's deviation from its route, the disabling of the transponder, and the apparent controlled flight for hours. The argument is that these actions could indicate deliberate intent. Another theory is hijacking, either by passengers or by an external actor, potentially involving demands or a plan that failed. However, no verified communications or demands were ever received, which weakens that scenario. Another theory centers on an onboard fire or mechanical failure that incapacitated the crew. In this theory, a fire could have disabled communications and forced the aircraft off course, with the plane continuing on autopilot until fuel exhaustion. This is plausible in general aviation terms, but again, without wreckage, it remains a theory. Another theory is sudden decompression or a catastrophic event that left the aircraft unable to communicate, with the plane drifting under autopilot. Variants of this theory imagine the aircraft becoming a ghost flight, continuing until it ran out of fuel. There are also theories involving more complex chains of events, including attempts to land elsewhere or partial control followed by loss of control. Some theories suggest the aircraft could have ditched near an island. Others suggest a high speed impact far from any planned search area. It is important to say clearly that these are theories. Some are more plausible than others based on data, but none can be confirmed without the main wreckage, the flight recorders, and a reconstruction of the final minutes. After the official underwater search ended in 2017, the next major chapter came in 2018 when a private search company, Ocean Infinity, launched a new seabed search using advanced autonomous underwater vehicles. This search operated on a no find, no fee basis, meaning the company would be paid only if it found the wreckage. The search lasted for months and covered additional areas, but it also ended without locating MH370. For families, that was another blow, but it also proved something. Private industry, using modern robotic systems, could search the deep ocean in ways that were not possible a decade earlier. The tools were getting better, the ocean was still difficult. Over the next few years, the question became whether new analysis could credibly narrow the search area enough to justify another attempt. Researchers revisited the satellite handshake data. Independent investigators proposed refined models. Some focused on how the aircraft might have flown along the seventh arc. Some proposed small shifts to the most likely impact zone. Some developed new drift models. Others explored unconventional sources of data, including weak signal radio propagation experiments that attempted to infer aircraft location from disturbances in global radio signals. Again, many of these ideas remain theoretical and debated within the expert community, but taken together, they kept the possibility alive that a new search could be targeted more precisely than before. That brings us to the newest searches. In March 2025, Malaysia announced it had agreed to terms with Ocean Infinity to restart the search, again under a no find, no fee arrangement with a reported reward structure for success. The planned area was described as about 15,000 square kilometers in the southern Indian Ocean, smaller than the earlier official search zones, and based on updated analysis that aimed to improve the odds. Ocean Infinity began a renewed campaign in early 2025, but the southern Indian Ocean is unforgiving. Weather windows matter, sea states matter, winter approaches in the southern hemisphere. In April 2025, Malaysia's transport minister said the search had been suspended due to bad weather and would be expected to resume later, reflecting the reality that even the best technology cannot operate effectively in relentless storm conditions. Then came the most recent confirmed restart. Malaysia's Ministry of Transport issued an official media release stating that the deep sea search would resume on December 30th, 2025, with Ocean Infinity recommencing seabed search operations in the southern Indian Ocean. The plan included a search period described as totaling 55 days. This was not described as a brand new open ended effort. It was framed as a focused campaign with a defined operational window. What is different about these newest searches is not just the calendar, it is the technology and the strategy. Ocean Infinity's modern approach uses advanced autonomous underwater vehicles, robotic subs capable of scanning the seafloor with high resolution sonar. These vehicles can operate for long periods, cover wide swaths, and return detailed imagery of the seabed. The search vessel serves as a mothership, deploying and recovering the robots, coordinating their patterns, and managing the mission in real time. The new campaign has also emphasized searching areas that are considered higher probability based on updated analyses, including refinements to satellite data interpretation, drift modeling, and lessons learned from what has already been covered. In other words, the newest search is not simply repeating the same grid, it is attempting to search the places that remain most plausible, including areas adjacent to or beyond the previously searched zones. That is the heart of the current strategy, to focus on what was not fully exhausted, what might have been missed, and what new modeling suggests could be the most realistic endpoint. It is also important to understand the constraints. Even 15,000 square kilometers is enormous under deep ocean conditions. The seafloor is not flat, it has ridges, trenches, and debris fields from unrelated sources. Sonar images can be ambiguous. A wreck can be partially buried, it can be broken into pieces across a wide area. It can be obscured by terrain. Finding a specific aircraft in that environment is like searching for a small object on a mountainous landscape in the dark using sound reflections. Still, the resumption of active searching represents something families have demanded for years: effort, not closure, because closure without evidence is not closure. Now, where do we stand today in terms of what is most likely? The strongest evidence points to an end in the southern Indian Ocean along the seventh arc, with the aircraft likely running out of fuel and impacting the ocean. The confirmed debris supports an Indian Ocean outcome. The satellite handshake analysis supports a long flight after radar loss. The absence of verified northern corridor evidence and the lack of radar confirmation across those countries makes the northern route far less likely. Within the southern arc possibilities, the debate focuses on how the aircraft was flown in the final hours. Was it under human control for a time? Was it primarily autopilot? Was there an attempt to glide or ditch? Was the final impact steep or controlled? These distinctions matter because they can move the likely crash site by tens or even hundreds of miles, and that is why the search remains unfinished. The difference between a few degrees of heading, a few minutes of flight, or a slightly different end of flight behavior can produce a dramatically different endpoint on the ocean. If the newest search finds the wreckage, everything changes. The flight recorders could reveal the state of systems, crew actions, cabin conditions, and the final sequence. The wreckage location would validate or falsify years of analysis. It would answer questions that have lingered for more than a decade. If the newest search does not find it, that does not mean the plane is unfindable. It means the probability remains spread across a vast environment, and the cost and effort of continued searching become harder to justify without new, credible narrowing evidence. This is where the mystery has lived for years, in the space between strong indications and missing physical proof. MH370 is not only an aviation story, it is a story about the limits of technology, the scale of the ocean, and the human need for answers. It is also a story about how global systems can fail in quiet ways. A modern airliner can vanish without a distress call. A flight can continue for hours without being located. An ocean can swallow evidence. And it is a story about the families who have lived with uncertainty for more than a decade. Every resumed search is not just a technical operation, it is an emotional event. It reopens hope, it reopens grief, it reopens questions, and it is shaped by the painful understanding that time makes everything harder. The newest searches for MH370 represent the best of what modern deep sea robotics can do, applied to one of the hardest search environments on Earth, guided by years of accumulated analysis. They are not guaranteed to succeed, but they are grounded in the idea that the mystery is not closed until the aircraft is found. And until that day, every conclusion remains provisional, every explanation remains incomplete, and every theory remains only a theory. What is real is the flight, the disappearance, the years of search, the confirmed debris, the southern Indian Ocean likelihood, and the renewed commitment to try again. That is the full story of why this mystery still matters and why the newest searches are being watched so closely, because somewhere on the seafloor, there may still be a final answer waiting to be found.